Can you spot the difference between the throws? Unless you look in great detail, it's pretty easy to miss because you're stuck only looking in one dimension, the front view. Let's add a second dimension, in this case, a side view. Of all of our throws, let's look at these two. First, let's look at the front view again. Now, let's add the side view. Due to our perspective from the front view, we're unable to actually see any of the horizontal motion. Typically from this angle, if we're trying to spot any horizontal motion, what we would be doing is we'd be looking for a size change. If this object were traveling towards you, you would see it get bigger and bigger and bigger and bigger as it approached the camera because it's taking up more of your view, right? That's why someone far away you can squish their head, but when they're up close, not so easy. I intentionally kept the camera far enough away so you couldn't detect much of a size change as that ball approached you in the second video. Here we are now outside the gymnasium in our athletic lot. What we're going to do is we're going to release a ball from a moving car. This is essentially going to be a horizontal launch. The car drives forward, therefore the ball that's in my hand is moving forward. Now before we do this, we want some kind of a baseline. So what I'm going to do is I'm going to just drop the ball from a car at rest. So we have some similar motion to compare to later on. Now I get the car up to speed, drive towards the cameras, and once I'm in view, I release. I know it happens really quickly, so let's watch it again. From the front view, just like in the gymnasium example we just did, it's tough to see easy, clear evidence of any horizontal motion of the ball. From the side view, however, very easy to see that horizontal motion. From the side view, watch the position of the ball as it falls. Not only is it moving forward, it's actually moving forward at the exact same speed as my hand. The ball stays under my hand the entire time until it hits the ground. When it hits the ground slows it down and it no longer stays under my hand, but while it's airborne, it stays under my hand the whole time. We share the same exact horizontal speed and therefore the same horizontal position. Now in this trial, we're going to look down from the perspective of me, the person dropping the ball. So as I go through and release the ball, what would you expect to see as the video plays? Well, in our first example, we saw the ball stay under my hand the entire time in the side view, so it should make sense that the ball stays under my hand the entire time from this new perspective from above. And sure enough, the ball stays right there under my hand until we see it hit the ground and slow down. This last camera angle, I tried selfie mode. I essentially stuck the camera out of the car, aimed it back so I could watch the car move forward. So the camera is moving forward the same speed as the car. Now the ball should stay under my hand the entire time. So when I release the ball, we see it fall. It's not a great camera angle, but it's actually good enough because of the reflection in the door. You can see the ball fall through the perspective of the camera, but then you can see the reflection in the door as the ball continues traveling straight down from this perspective. From someone at the side view camera, they're going to see that ball moving sideways just like we've done the previous 3 trials. But from the perspective of the car, it's traveling straight down until it hits the ground again, because when it hits the ground slows it back down. So the purpose of all these videos is to try to remind us and to really show some solid proof and evidence that the two dimensions, vertical and horizontal, do not affect each other. What we saw was that if you cut out one perspective altogether, you can't even see the side-to-side motion depending on your perspective. So keep in mind for our test, horizontal and vertical components are independent of each other. They share a common time, and that is it.